Unit 4, Module 2, Session 2, which is called Constant Difference. All right, so we're going to continue our work with subtraction. We will begin this lesson with another subtraction problem string, and we will then discuss the problems from the previous lesson. You are going to need a pencil, and you're also going to need to turn to one of the blank pages in your math workbook for this, all right? So I'll give you a little bit of time to get to a blank page, and then we will start our problem string for today. All right, we're going to go ahead and get started. So the first one in our problem string is going to be 256 minus 229. So I kind of want you to think back to the problems that we did earlier, okay, with those problem number lines that we were doing yesterday. And I'm going to show you one strategy. So you may have already found the answer of 256 minus 229, and you may have just done it by simply going like this: 256 minus 229. And you know that you can't take away 9 from 6, so this then becomes a 4, and then this becomes a 16, and then you would end up with a 7 and a 2, right? Okay, so you may have already figured that out. But if you flip to the next slide here and take a look at what we have here, we have it on a number line. So basically, if I have 256, and I start by just taking away 200, then I end up with 56, okay? I haven't taken away enough yet. Okay, I got to take away another 20 to get to 36. And then I take away another 9, and I'll get to 27. So I kind of took away 229 in chunks. So if you remember from yesterday, that was called the removing or taking away. All right, let's take a look at the next problem now. And that one is 256 minus 229. So same problem, but now I'm showing you the differencing strategy that we also talked about yesterday. All right, so with this one, you essentially start with 229, and then this is the one where you kind of want to get to that solid number that we were talking about of 230, okay? So I only needed to jump 1, and then from there, I'm at 230, and I simply just need to get to 56. So if I just jump 26 more, I'm at 56, and I can see that 1 plus 26 equals 27. So that one was called the differencing strategy. Both of them got me to the same answer of 27, okay? But you'll just see that it was done a different way. Okay, so now you should be all kind of refreshed from yesterday, and we're going to talk about how to get to the next problems in the problem string. All right, so here's the first problem. So I just wanted to kind of talk about some stuff here. So this number right here, the bigger number in a subtraction problem, is called the minuend, and that's simply a quantity or a number from which another number is to be subtracted. So it's a bigger number. The other number is called the subtrahend, which is a quantity or number to be subtracted from another number, which is just the smaller number. All right, so the first problem in this string is 262 minus 235, all right? So thinking back to our number lines here, if we do it this way, we have 262 minus 235. I've got my 262 over here, and I've got my 235, and I simply am going to jump to the 262, and first I'm going to get to a solid number of 240. So in order to do that, I have to jump 5. To get from 240 to 262, I'm going to jump another 22, all right? And you will see that I have jumped 27. So that simply means that 262 minus 235 equals 27. All right, so there's that one. I'm going to show you the next problem in our problem string. Okay. So we have 260 minus 233. Notice that the numbers are very close to the ones that we just talked about. 260 minus 233. You actually might be able to do this one in your head. So think about it for a little bit, and then I'm going to show you the next slide with the same problem using a number line, okay? This one's actually pretty easy. So if I've got 233, I could simply think about getting to 240 if I wanted to. And from 233 to 240, ooh, that would be 7. And then from 240 to 260 would be another 20. So I have essentially gone 27 spaces. So 260 minus 233 equals 27. Very interesting. It has the same answer. Okay, so there's that problem. Let's go on to the next one here. The next one is 254 minus 227. Okay, so think about that one for a minute. Notice that the numbers are still similar, okay? All right, moving on. So 254 minus 227. I'm going to go ahead and flip slides here. So if I start with 227 and I'm jumping to 254, ooh, it's only 27 spaces. Now from 227, if I were just to make a little jump to 230, okay, that would be 3 spaces. And then to get from 230 to 254 would be another 24 spaces. So I have gone 3 plus 24 spaces again. There's that 27. So 254 minus 227 equals 27 again. All right, so we're going to move on to the next problem, which is 257 minus 230. Ooh, this one actually looks pretty easy. And the reason why is because this one right here, this subtrahend, it ends in a 0. It is a multiple of 10. And this minuend right here, I think I can easily subtract this from that. So let's see here. Ooh, oh my gosh, look at that. From 230 to 257, well, I'm very close here. I'm already at a solid number. So to get from 230 to 257, I really only need to go 27. So again, I have ended with 27 as my answer. So thinking about all of these problems, okay, the answer is the same from one problem to the next in this string of problems because the difference has been held constant. So that is what this lesson is called, that constant, from one to the next. So 262 minus 235, remember, was 27. 260 minus 233, again, that was 27. Notice that this one ends in a 0, and so does that one. Just keep that in mind for a second. 254 minus 227, that also equaled 27. And finally, 257 minus 230 also equaled 27, okay? So in the second problem that I want you to look at here, so this second one, this one right here, 260 minus 233, both of the numbers, minuend and subtrahend, have been decreased by 2 from this problem. Do you see that? They have been decreased by 2. Interesting. So if I just decrease by the same numbers, I'm going to end up with that same answer. Now when you look at the third problem, which is right here, 254 minus 227, both numbers have been decreased by 6. So if I go from 262 to 254, that's take away 6, all right? If I go from 235 to 227, again, taking away 6. So you'll notice that, again, my answer is 27. And then finally in the last problem, so let's take a look at this last problem here for a moment. 257 minus 230. Both numbers have been decreased by 3. I'm sorry, increased by 3. And the subtrahend is a multiple of 30, okay? So increased by 3 from this one to this one. So plus 3 and plus 3. So you'll see where, and I apologize from before, this was decreased by 6, and this was decreased by 6. I was confusing there. Sorry about that. So yes, these have been increased by 3, and the subtrahend is a multiple of 3. So as long as I'm decreasing or increasing the numbers I started with by the same number, I'm going to end up with the same answer, is what this constant is really trying to teach us here. All right. So what I want you to do now is turn to this page in your student book that we completed yesterday, page 139. I know that we completed it yesterday, so we're just going to take a little bit of time to look at it real quick here. Not too much time, but just a little bit. All right, so here are the answers to that page, which, yes, we did this yesterday, so no need to get too crazy here, but I just want you to listen. So if you look very carefully at problems problems 1 and 2, right here, problems 1 and 2, you'll probably notice that they have the same answer, kind of like with our problem string, okay? They have the same answer. Interesting. All right, now if you take a look at problems 3 and 4, there's a definite relationship between the differences or the distances in these two problems. So as you see here, you jumped 50 and you jumped 50. And so the numbers are very close together. So it's just interesting how this kind of turned out. And then again, if you look carefully at problems 5 and 6, sorry, I don't know what's going on here. I'm still getting used to this. If you look at problems 5 and 6 here, there is, again, a definite relationship between the two problems. Someone born 2 years earlier than someone else will be obviously 2 years older. So, okay. So I just wanted to, bring that to your attention real quick, just in case you didn't notice it yesterday. All right. And then this is a student book page that we did not do yesterday, student book page 141. So I want you to go ahead and turn to this page because we did not do this one yesterday. I'm going to go ahead and read the directions. It says, Sam's 4th grade class is working on subtraction. Help Sam solve the problems below. Which strategy works best for you? So if Sam's teacher is 33 and Sam is 9, how much older is Sam's teacher than Sam? Okay, so basically what we're trying to figure out here is what 33 minus 9 is. So if I were to take my number line here and go like this, and I kind of start with 33, and if I just simply get to a solid number of 30, okay, so I'm at 30, and I've only gone 3. And I need to go 6 more to take away that 9. Oh, sorry, 6. I apologize. 6 more. I end up at 24, which tells me that 33 minus 9 equals 24 years old. Okay? Now, looking at the next problem. Sam's art teacher is 51. How much older is Sam's art teacher than his math teacher? All right, so his art teacher, then his math teacher. So I'm going to do this on a number line as well. So if his art teacher is 51 years old, okay? And how much older is Sam's art teacher? So we know that Sam is 9, all right? And his math teacher is 33, sorry. So from 33, I want to get to a solid number of 40. So that was 7, okay? And then to get from 40 to 51, that's pretty simple. I just add 11 more. And so now 7 plus 11 more, that's 18. So Sam's art teacher is 51. How much older is his art teacher than his math teacher? 18 years older. Okay? And then finally, Sam has to solve the problem 91 minus 76. Sam says it is easier to start at 91 and go back to 76 than to take 76 away from 91. Let's think about that for a second. Do you agree or do you disagree with him? Well, I'm going to go ahead and say that, yes, I agree. And you may feel differently, but I'm going to go ahead and kind of solve it on a number line because that's what we've been doing already. So if I solve this one on a number line, And I've got 91, and I'm trying to take away 76, right? Well, I'm just going to go ahead and jump to 90 because that's an easier number to work with. So I've already taken away 1. I'm not close enough yet, so now I'm going to take away 10 just to get to 80. So I'm trying to get closer to 76. Now from 80 to 76, if I go 4 more, now I just have to think about how much I've actually subtracted. So 1 plus 10 plus 4, so that's 15, okay? So, which is much easier than going like this, 91 minus 76 and all that kind of stuff. This, to me, seems a lot easier. So, and then last but not least, we're going to go ahead and solve these review problems. So, find the sum for each. Well, I know this is really hard to see, so I wonder if it'll let me zoom in here. Ooh, look at that. I get to zoom in, and it's really hard to see, but it's 1/10 plus 1/100th. Ooh. Well, I know that 1/10 and 1/100th. So 1/10 is really 10 hundredths, right? Ooh, this is going to give me a hard time, isn't it? All right, so 1/10 is 10 hundredths, and 1/100th, if I add those together, I have 11 hundredths. Okay, the next one is hard to see, but it says 5/12 plus 3/12. Well, that's pretty easy. That's 8/12. Now, 8/12, I can simplify it because right now it's not in simplest form. I can find numbers that go into both 8 and 12. I can divide them both by 2, and I'll end up with 4/6, but it's still not simplified because I can divide them both by 2 again, and I can end up with 2/3. So 5/12 plus 3/12 is either 8/12, 4/6, or 2/3. All of these are equivalent fractions. And then finally, 1 and 1/4 plus 3 and 3/4. Well, I know that 1 plus 3 equals 4, okay? And 1/4 plus 3/4 equals 4/4 or 1 whole. If I add 4 plus 1 more, I have 5 altogether. And now I'm finding the difference. 2 3/8 minus 5/8. All right, well, 2 3/8. If you remember turning these into improper fractions first, if I take my denominator times my whole number and then add my numerator, so 8 times 2 plus 3, 16 19/8 minus 5/8 will give me 14/8. 8 goes into 14 one whole time, and I have 6/8 left over. Okay, so there's that one. For the next one, I know it's hard to see. I'm going to switch colors, but it is 3/4 minus 1/2. 1/2 is the same thing as 2/4. So this is the same thing as 3/4 minus, 2/4, which equals 1/4. And then the last problem is 8/10 minus 15/100, which is the same thing as 80/100 minus 15/100. So I would have 65/100. So there's that page, student book page 141. You can go ahead and complete this page if you haven't done so with me, and then I want you to just upload it into Seesaw for me, okay? And then for the next one, this is a new page. So this is student book page 142, rolling dice. So Austin rolled he rolled 6 4 to 9 dice, and he arranged the dice and made these 3 digits, 548 and 796, okay? What is the sum of Austin's numbers? So our work can really vary here, but the sum of these numbers, I'm going to use one of the strategies that we used before. So I'm essentially trying to figure out what 548 plus 796 is. I know that kind of looks bad, sorry. 796 is really close to 800. It's only 4 away. So if I turn this into 800, I'm using the give and take method. So if I gave 4 to 796 to turn it into 800, I'm essentially taking away 4 from the top number, so it's 544 plus 800. So my answer is 1,344 because 4 plus 0 is 4, 4 plus 0 is 4, and 5 plus 8 is 13. Okay, so there's that one. The next one is, what is the difference between Austin's numbers? With this one, I can use a number line like we were doing before. And so I've got 796 and 548. Okay, I'm just going to jump 200 real quick here. So 796 minus 200, that'll get me to 596. Okay, and then 596, I'm going to jump 40 to get me to 556. Okay, then I'm going to go 8 more to get me to 548. So if I add all of my jumps together, that's 200 plus 40 plus 8. So I've jumped 248 times, which means that 796 minus 548 equals 248. What is the largest 6-digit number that Austin can make with the numbers that he rolled? Well, the largest number I see is 9. The next largest number I see is 8. So I'm going to kind of cross the numbers out as I go. And then I see a 7. And then I see a 6. I also see a 5. And I see a 4. So the largest number I can make is 987,654. The next one says, what is the smallest 6-digit number that Austin can make? Well, if you really think about that carefully, it's really the reverse of the top one. So it's 4, 5, 6, 7, 8, 9. 456,789. Number 5 says, Austin rolled the dice again, and this time he made these numbers, 467 and 594. Austin says he can add 460 and 601 and get the sum of 467 and 594. Do we agree with him or disagree with him, and why? I want you to think about that for just a little bit. Take a little bit of time to think about that. And if you think really carefully, yes, I agree with him. And I agree with him because from 467 to 460, that's only 6 away. And from 594 to 601, that's also only 6 away. So like we were talking about earlier, as long as I add or take away the same number, my difference is going to be the same number as well. And then the last problem on this page is Austin says that he can find the difference between 467 and 594 by finding the difference between 473 and 600. Do you agree or disagree? And then yes, again, we can agree because if I just simply add 6 to both of the numbers, I have 473 and 600. So again, I'm going to end up with that same number. So that, my friends, is how you do this page. So I'm going to show you the last slide here, and the last slide is your homework for tonight. So yesterday you did page 75. So tonight I want you to do page 76 in your home connection book, and then go ahead and take a screenshot of it and submit it into Seesaw for me. And I will see you guys tomorrow. Have a great day.